Two trains, A and B, are moving in the same direction along parallel tracks. At a certain moment in time, A is at a point called the origin, and its distance from the origin in meters, x seconds after it passes the origin, is given by the function f of x maps to 10x minus a half x squared. At the same instant that A is at the origin, B is somewhere else, and its displacement from the origin x seconds later is given by the function g of x maps to 5x plus 12. Part 1. Determine the position of B when A is first at the origin. Well, A is first at the origin when x is equal to 0. Then the position of B is given by g of 0, which is equal to 5 times 0 plus 12, which is 12, i.e. B is 12 meters from the origin. So when A is at the origin, B is 12 meters from the origin. Part 2. Using the same axes and the same scales, draw the graphs of y equals f of x and y equals g of x for x values greater or equal to 0, less than or equal to 8. Well, the browny coloured graph, our linear equation here, is our g function, which is 5x plus 12, and our quadratic, so our n-shaped graph, this is our f function, which is 10x minus a half x squared. Part 3. Use mathematical tools, graphs, numeric and algebra to determine the times at which the two trains are level with each other. So what we're going to do is let f of x equal to g of x. So we're going to let 10x minus a half x squared equal to 5x plus 12. So 10x minus a half x squared equals 5x plus 12. We're going to bring everything over to the same side. So the 5x comes over the equal sign, becomes minus 5x. The 12 comes over, becomes minus 12. So we get 10x minus a half x squared minus 5x minus 12 is equal to 0. Then we simplify by putting the 10x and the minus 5x together, giving us plus 5x. So we get minus a half x squared plus 5x minus 12 equals 0. So we don't want minus a half x squared, we want x squared. So we're going to multiply across by minus 2 to get rid of the minus half. So minus a half x squared by minus 2 is x squared. 5x by minus 2 is minus 10x. And minus 12 by minus 2 is plus 24. Factorising, we get x minus 4 times x minus 6. Solving, we get x is equal to 4 and x is equal to 6. So if we were to draw out our graphs and have a look at the points of intersection. So remember, this is our g function, this is our linear function, and this is our f function. This is our curve. Now it's very difficult to see in this graph the points of intersection, but if we were to zoom in on our graph, we would see that that's the first point of intersection, which actually lines up with 4 on our x-axis. And this is the second point of intersection, which lines up with 6 on our x-axis. So again, x is equal to 4 and x is equal to 6. Part 4. Suggest how drawing a single graph could provide a different method of finding the times at which the two trains are level with each other. So what we could do is construct the graph of y equals x squared minus 10x plus 24. So this is the equation we got in part 3. And determine where it cuts the x-axis. So I've drawn out the graph y equals x squared minus 10x plus 24. And we can see it crosses the x-axis at 4 and 6. So getting the same answers as part 3.